morning everyone. This is Dr. GVR Seshagiri Rao, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today in this session, I would like to explain how to solve fluctuating stress problem by using Goodman line method. So here the problem given, a circular bar of 500 mm the length is supported freely at its two ends. For the length of the beam is 500 mm and the freely at its two ends. Okay, it is acted upon by a central concentrated cyclic load. So what is that value? The minimum value is 20 kilonewtons and the maximum value is 50 kilonewtons. So it means here also the load varies from minimum to maximum. Minimum 20 kilonewtons to maximum 50 kilonewtons. Determine the diameter of bar by taking a factor of safety is 1.5 and the size effect is 0.85 and the surface finish factor is 0.9. So here the given some size factor and some surface finish factor. So these all are mainly affecting on endurance limit, the size effect and the surface finish factor effects. Okay, so how to calculate the actual endurance limit when these factors are affecting? And then the material properties are given. The ultimate strength is 650 megapascal and yield strength is 500 megapascal and endurance strength is 350 megapascal. Clear? So here two values also given. The ultimate strength value and yield strength value also given. But we don't know which method you have to follow. Either Soderberg or this one, Goodman line method. So that's why. So I will explain how to solve these type of problems. First of all, write down the given data. So the given data, the length is 500 mm. The minimum load, you can represent with W or P also, no problem. So W minimum is 20 kilonewtons, convert into newtons. So 20 multiplied with 10 cube newtons. So similarly, W max, that is maximum load is 50 kilonewtons. And factor of safety 1.5. So if you don't know the factor of safety, you can assume the factor of safety for a given material. And size factor 0.85 and surface finish roughness value 0.9. These factors also sometimes may not available in the problem, and that time you can assume approximate value factors you can take. Ultimate strength 650 and sigma y is 500 megapascal. Endurance limit value is 350 megapascal. Okay. So here first take d is the small d, the diameter of the bar, and we know that the maximum bending moment, the formula bending moment is equal to WL by 4. So why? Because this here the given problem, given a circular bar, they act as a simply supported the beam. Here two ends are fixed. So WL by 4. So W value you know, known value, and the L also you know. So substitute those values in this empirical relation, you will get a bending moment. Similarly, the minimum bending moment also calculate, and you will get 2550 kilonewtons. So and then maximum bending moment and minimum bending moment. Immediately calculate the mean bending moment or average bending moment value. So by using empirical relation, M max plus M minimum by 2. Similarly, calculate variable bending moment. So variable bending moment by calculate by using this empirical relation, M max minus M minimum by 2. So what is the bending moment maximum? Already we calculated in the first step, 6250 kilonewtons, and the minimum bending moment value is 2500 kilonewtons. So take their average, you will get variable bending moment. And then so calculate the section modulus of the bar by using the empirical relation pi by 32 into dq. So here the d is diameter of the bar. So we don't know this diameter of the bar. We have to calculate this diameter of the bar by using fluctuating stress formulas. The mean or average bending stress is bending moment maximum by section modulus value. So we will get the mean or average bending stress. See here, in previous, in the first step, we have calculated maximum bending moment and minimum bending moment, and also the variable bending moment only. So we have not calculated the average bending stress or the mean bending stress. For any Soderberg the line method or for Goodman line method, they need the mean stress value or a variable stress value. Clear? So then only we can calculate unknown values. So that's why. So immediately calculate the bending stress the value by using this empirical relation m by z. Already we know this. All these relations we have studied in mechanics of solids. Clear. So similarly, variable bending stress calculate according to the Goodman line. So first you take the Goodman line method. So why? Because here the ultimate stress value also given and yield stress value also given. Suppose when you are given problem, only yield stress is value is available. That is depends upon the Soderberg line method only. But here two values are given. The ultimate stress value also. Suppose if not given this yield stress value, only available ultimate stress, then you can go for Goodman line method. But two values are there. So that's why here by using two methods, first you have to calculate the diameter of the bar and then finally take the larger value of these two. Okay? So first apply the Goodman line method. So already you know the formula 1 by factor of safety is equal to mean stress upon by ultimate stress plus sigma variable stress by sigma E. But why here multiplied with Kf and K surface and K size? Here factors, some factors values are given in a problem. That is fatigue stress, stress concentration factor, and KSU surf is surface roughness factor. This KSZ represents a size factor. Clear? So first you multiply with these factors to the this endurance limit. That is the actual endurance limit. So whenever you multiply the endurance limit value with these factors, you will get. So after considering stress concentration factor, you will get the actual endurance limit value of the material. If you don't know, so not given the surface factors values are not mentioned, are not considering any stress concentration value. In that case, no need to multiply these factors. Clear? So here given. So that's why I have multiplied this KF factor and surface finish factor and size factor. Clear? After that, you will get the value in terms of D. In terms of D. So that is 139 139 to 10 cube by dq. So this is the unknown value D. Clear? So you need to calculate diameter of the bar. Here obtained the value is 59.3 mm. You can say 60. So similarly, calculate the diameter of the bar according to Soderberg line. Why? Because here yield stress value also given. So apply this formula, the Soderberg line method. 1 by factor of safety is equal to sigma mean by sigma y plus sigma v by sigma e. So here also multiply the surface finish factor and the size factors and fatigue stress concentration factor, the given the endurance limit value. So you will get a final value is 62.1. So previous, according to Goodman line method, obtained value is 59.3. You can say 60 mm, and in second case Soderberg line method obtained 62.1. Clear? So here two values are available D. So which one you have to take? So larger value. So taking larger of these two values. So that's it. That is our final diameter of the circular bar. Here 62.1. You can say 64. The diameter of the bar is 64 mm. So this is the procedure for fluctuating a stress problem. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.